Guys are getting a little crazy. What's going on?
Danny's being racist.
No, I'm not.
Danny said if I don't cut my hair every 2 days, I have an afro.
How's that?
That's mysterious.
Jonah, what's number one? That's
Oh,
about.
that's funny.
Listen, please.
Well, you see here. So the domain is definitely 10.
Yeah, what else?
And then 20. Michelle, and then 30. And then 9.
Good. The X values, right? 10, 20, 30, 60, 90. What's the range, Ryan?
500.
Yeah. For Y, it's 5 and 100. Easy stuff, right? All right. Is number 2 a function or not? Does every X have one and only one Y? Yeah. Right? You just have one and only one number of pets, right? There might be a lot of pets, but just one number of pets, right? What about cities? Do they all have one and only one zip code?
No.
No. Right? Some cities are really big. They have more than one zip code. So that is not an example of a function. How about number 4? What's the domain? Danny? Yeah, -4 to +4, right? The X values go from there to there, right? What about the range? 3 to -3. You guys agree with Lindy?
Yeah.
Yeah, that's correct. All right, I have it written. Oh, I have to undo it, don't I? I have it written in roster form, not roster form, but set builder notation, or you could do it in interval form too. Usually, to make it quick, we've been doing interval form, -4 to 4. The brackets mean we're including that number. If I use parentheses, we mean we're not including the number. We haven't done that for a while. Okay, and then the range. Either way is fine. You want to write an inequality, or you want to write interval notation, which is a little bit more of a shorthand method. You can do that. Okay, and then 192, 2A, D, and F was this problem. You guys probably didn't get that, but there it is. It's the function g of x equals 2x squared plus 3. So g of 3 means to put a 3 in place of the x. So you do 3 squared 9 times 2 is 18 plus 3 get 21. G of 1/2 means put 1/2 in for x. So 1/2 squared is a fourth. 2 times a fourth is a half. A half plus 3 is 3 1/2. When you get something a little bit more than just a number in there, okay, you're squaring c plus 5. A lot of kids will just put c squared plus 25. Remember, c plus 5 squared means c plus 5 times c plus 5, right? So you got to FOIL it out, and you'll get an outside of 5c and an inside of 5c. So that's where the 10c comes from. Okay? And then simplify it, distribute the 2, and 50 plus 3 is 53. Okay? So you should be able to handle a problem like that. Okay, any questions on warming up? All right. For number 3, you had 6 answers you were supposed to do. I think some of you just did the first one. Okay, but number 3 is the square root of 5 for A, 3 for B, 3 for C, D is the square root of 21, E is the square root of r squared plus 2r plus 6. So there you have to square that r plus 1. And then FOIL it out and then add the 5 to it. That's where the 6 came from. And then for F, you're supposed to substitute negative c in there. When you square negative c, you get c squared. So it's the square root of c squared plus 5. Any questions on any of those parts of 3 that you need me to do? Okay. Number 6 is really easy. It tells you t of x equals 5. So no matter what you put in for x, what's the answer? 5. Yeah. The only one that changed and wasn't 5 was D because it had T of 3 plus T of 1. So it'd be 5 plus 5 or 10. All right, so don't overthink that. It's just telling you no matter what you put in for X in the T function, the answer is 5. Number 9 was that piecewise one. So P of negative 4 fits in the top piece. It's less than 2. So you go 3 times negative 4, negative 12 plus 1, so you get negative 11 for 9A. For 9B, the square root of 5 is 2.2 something. So that's bigger than 2. So you put it in the second or bottom piece, and you get 6 when you substitute the square root of 5 in for X. For part C, you're going to put C in the top function for X, so it's just 3 times C plus 1, because it told us C was less than 2. And for D, that told us that K was greater than or equal to 1, so it's 1 or more. So if I add 1 to it, it's more than 2, which would be the bottom part. So you're going to put K plus 1 in for the X squared and FOIL that out. Get negative K squared minus 2K plus 10. Number 9, I think I actually have it here. Yeah. So there's the answers for that. Did it just, I think it just froze on me. All right, so any questions on number 9? Do you understand the piecewise ones? We okay? Let's see if this will go and not get frozen today. Numbers, I did numbers 12, 15, and 18 also. It's kind of slow, isn't it? There it goes. No, that's not it. There we go. Let's just do this and get rid of the shape. All right. Number 12. It's just a linear equation. We talked about that yesterday, right? All linear equations are functions except which one? Which line is not vertical? Thank you, Evan. Okay? And we're going to talk about the vertical line test today. That really makes it easy to tell. For 15, what I did is I made an XY table. And remember, for every X, how many Y's are you allowed to be a function? 1, right? So when I put 0 in for X, I got 4. 4 plus 0, 4 minus 0, that's the same range. But when I put 4 in here, the square root of 4 is 2. 4 plus 2 is 6, and 4 minus 2 is 2. So for this X, I had 2 different Y's. And I used 0, 4, 9, and 16 because I had to do the square root. So I used perfect squares to make it easy on me. All right? But right here, when I put 4 in place of the X, I get 2 Y's, so it's not a function. Okay? For the absolute value, no matter what number I put in for X, I get a whole number. Or not a whole number, but a positive number. Thanks. All right, so when I put the absolute value of 1, I get 1, plus 5, I get 6, right? If I put negative 1 in for X and add 5, I get 6. Is it okay that 1 and negative 1 have the same line?
No.
Yeah.
Oh, no, that's a negative.
If they were both positive 1 and 6, it's still one Y, right? So no matter what I put in for Y, I'm sorry, no matter what I put in for x, when I take the absolute value and add 5, I'm only gonna get one answer. I'm not gonna get a multiple answers, okay? So that is going to be a function, okay? When you graph an absolute value, it looks like a V, okay? We'll talk about the vertical line test in a few minutes, and you'll be able to tell just by looking at your V that it is a function, by looking at the vertical line test. Then for the rest of it, 21 and 24, you just look for the x's and see if any of them repeated, all right? And for 21, none of the x's repeated. You didn't get a different y, so that is a function. And for 24, same thing. The x's didn't repeat, so it is also a function. Okay? Questions on anything that I didn't go over? Lily, did you do your homework? Yeah? So today we're going to graph some of these functions. You can use our calculator. We can use an XY table. You can just plot the points. You guys know how to plot those. How many is there? 6 points there? 5. 5 points. All right. So you just plot them. If they just give you a set of points, you just plot the points. You don't connect them. All right. If they give you an equation, then you're going to connect them. Okay. So the way I would do this, you could do an XY table, but what's easier? What's this number? Y-intercept, right? So there's our y-intercept right there. And what's this number tell us? The slope, right? So from our y-intercept, we can rise 2 and run 1. Remember that? Okay? Or if you go down 2 negative and left 1 negative, 2 negatives make it a positive, so you're still in the same line. All right, so that's how I would do it. You could put it in your calculator too and look at your table of values. All right, so we should have a problem doing linear functions and graphing them, right? And then absolute value, again, you could do an XY table. You know, a lot of times we'll just put -2, -1, 0, 1, and 2. Let's see what happens. What's -2 minus 1?
Or no, -3.
-3. What's its absolute value?
3.
What's -1 minus 1? -2. What's the absolute value?
2.
What's 0 minus 1?
-1.
What's the absolute value?
1.
What's 1 minus 1?
0.
What's the absolute value?
0.
What's 2 minus 1?
1.
What's the absolute value?
1.
Okay? So there's some points. -2, 3. -1, 2. 0, 1. 1, 0, and 2, 1. If I go to 3, what's 3 minus 1? 2, and what's the absolute value? 2, so it should be there. So there's my V for my absolute value. You guys remember where it is on your calculator, absolute value? Yeah, it's in math, then what? Number, good. So if I want to graph a line, that line, okay, that absolute value equation, you go to your y equals, all right, then you go to math, and then move over 1 to number, NUM. And then absolute value is that first one, that ABS. Then we'll just put x minus 1, close it up, and then hit enter, and then hit graph. And there's our V. Okay? You can use your calculator for those as well. All right? Just got to get y by itself, if it's not already by itself. When you do, use the graphing calculator. Okay? How about a piecewise function? Any ideas?
You put on the same thing that I put on 4. -2 and 1, 2.
So you want to use a XY table? Okay? That'll work. Let's do it. All right, so let's do this part in red. All right, so what numbers do I use for x? What's it telling me?
If it's less than
It has to be like,
Right, so what numbers can I use?
negative and
I
zero.
can I use 1?
Yes.
Yes. And then 0, negative 1. I can use those, right, according to this. This is telling me what the domain is for this part of it, or this piece, right? What's the answer for all of those? Yeah, they're all 2.
Huh?
Or I guess it's not y, we're using n of x, right? What's it say? When x is less than 1, what's the answer? 2.
What is then the 1 and the 0 and the negative 1?
What's that say above there?
Okay.
Okay, what's that say?
But like, I
X
don't
is
know
less
what's
than
the
or equal to
negative
1.
Or what's the 2?
N of x equals 2, comma, if x is 1 or less. So all these numbers are 1 or less. So what's the answer? 2. All right? Good question. Making sense? So for that piece, all right, I got the point 1, 2, 0, 2, negative 1, 2, and negative 2, 2. What's that look like? Horizontal line, right? So that's what the red piece looks like. What's the blue piece look like? What numbers should I use for x now? Anything above 1, right? So 1 point whatever, right? And 2 and 3 and 4, right? So 1 point whatever is what? Is my x. So what's it equal? What's it? Yeah. Say that again, Evan. Itself. So this is 1 point whatever. When this is 2, what's this one? 2. When this is 3, what's this one? When this is 4, what's this one? Okay, so for the blue one, you need to put above the 1 a circle, because if it actually equals 1, what's the answer? 2. Anything above 1, though, it's itself, right? Where's 2, 2? 3, 3. 4, 4. So that's the blue part.
Wait, why do you have to have that hollow circle?
Because at 1, the answer is 2. But anything greater than 1, just past it, like 1.1 or 1.0001 or 1.5, all right? That's above 1, right? So whatever, any number that's above 1, the answer is itself. So I put a circle above the 1 at 1, because it would be 1, 1 itself. But remember, when it actually equals 1, the answer says it's supposed to be 2. All right? So there's the dot at 1, 2, and all the others are 2s that way. Here, anything past 1, it's whatever you say it is. All right? So 2.5, the answer is 2.5. 6, the answer is 6. Okay? Again, you can use your calculator. Right? It's not going to do this part. That's what you got to figure out. But it'll do the horizontal and that y equals x part. All right? Go to your y equals. Clear that out. Put 2. Enter. And x. Enter. And then hit graph. There's the 2 one. And there's the x one. You just got to figure out where you got to put your circle and dot, where they kind of separate, where the pieces separate. Okay? Does that make sense, what I did there? Okay, so remember, when we were doing these yesterday and we were just giving you a number, you had to figure out where the number fit, right? 'Cause this is the domain they're giving you. Remember, the x values are the domain. All right, the answer is your range value. Okay? A little bit of thinking has to go on today. All right? And I know you guys love to think. All right, so there's how you graph a piecewise function. All right, vertical line test says this. If any vertical line passes through more than one point on the graph of a relation, the relation is not a function. Okay? So that's a real quick way if you want to figure out if an equation is a function, graph it and then use the vertical line test. Wherever you draw a vertical line, it only hits once, function. If it hits more than once, not a function. So this one is a function because no matter where I would draw that blue dashed vertical line, it only hit it in one spot. Over here, wherever I drew my line, I'm going to hit it in more than one spot, right? So that's why it's not a function. So we use the vertical line test to help us out. Olivia Doherty, is that a function or not? Does it pass the vertical line test? Good. Soren, does that pass the vertical line test? No. It'll hit, wherever I draw a vertical line, it's going to hit in two spots, right? So that's not a function. Christian, is this bottom one here, left, is that a function?
No.
Good. What if one of these was a circle? Would it be a function then? Yeah. The dots mean we're including that point, right? That number. So we got a 1, -2, and a 1, +2. So that 1 has two different y's, right? It's not a function. But if one of those was a circle, like we did in our piecewise, it'd be a function, okay? Because that means we're not really including that point, right? What about this upside down parabola? Is that a function? Yeah, it passes the vertical line test. We good on the vertical line test? Remember that from last year, I hope? We did do that last year. All right. Our functions sometimes increase, decrease, or stay constant, okay? This left part, going down left to right, what do you think that is? Increasing, decreasing, or constant? Decreasing. Okay, so smart. What about this middle part? What do you think that is? Constant. Good. What about this right part? Increasing, right? So left to right, if it goes this way, it's increasing. Left to right, if it goes this way, it's decreasing. Right, Andy? So, what is my interval? What's my interval or my domain? What am I looking at if I say interval or domain? X values. What X values is it decreasing? From there to there, right?
So 3 to,
Well, is that 3? -3. What is that? -8? I think this is 10, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So decreasing, my interval is from -8 to -3. We could just do an interval notation if you want.
does it matter which way goes first?
We usually put it in the order from left to right. Okay. Yeah, so I would say yes. All right. Where's the constant part?
-3 to 4.
You guys agree with Olivia? Right. She's right. -3 to 4. And then from here to here is what part? The increasing, right? So what's that? 4 to 10? So you may be asked to tell the domain where a certain graph or function is increasing, constant, or decreasing. You will on the quiz Friday. You have something like that. Make sense? Again, where kids mess up on this is they think about the y interval. We're not thinking this way. We're thinking horizontally, the X, the domain, okay? All right, last thing for today. Functions, what did we say? Every X has one and only one Y. If it is a one-to-one function, the function, so every X has one and only one Y, and also every Y has one and only one X. So it has to pass the vertical line test and the horizontal line test to be a one-to-one function, right? So does this pass the vertical line test? Yes. Does it pass the horizontal line test? No. That's a function, but it's not one-to-one. Does this one pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. So the one on the right is a one-to-one function. So it's a special type of function. Get it? Yeah? Good. You okay, Olivia? Okay. We good? Any questions? All right. There's your assignment. And I still haven't got it in Canvas yet. I'll work on that right now. I took the pictures, but I didn't get it loaded.